This week we're going to be looking at finding the tangent line of a vector curve. So the question is, find the tangent line to r of t is equal to 2 sine of t to cosine of t, tangent of t, at the point negative root 2, negative root 2, 1. The first thing we have to do is find out for what value of t this point is satisfied. So if we do it component-wise, we know that 2 sine of t is equal to negative root 2. So we know that sine of t at this point is negative root 2 over 2. Similarly, we know that the cosine is also negative root 2 over 2. And the tangent is 1. So where on the unit circle is this? Well, we know that sine and cosine are both going to be negative, which means we have to be here in quadrant 3. And we also know that for tangent to be equal to 1, the sine and the cosine have to be the same. And that happens right here at 5 pi over 4. Now, if you can't remember how to do that, you can look at this triangle here. And we know that this has to be 1, and that those two sides are equal. And you can find out that these are root 2 and root 2, and they obviously have to be negative because they're in quadrant 3. Negative root 2 over 2, excuse me. So we know that t is equal to 5 pi over 4. So now what we do is we take a derivative of our r of t. So r prime of t is equal to 2 cosine of t, negative 2 sine of t, and secant squared of t. Next we plug in our t value that we found, 5 pi over 4. So r prime of t is going to be equal to, if you simplify it, you get negative root 2, and 2. And that just comes from plugging this t into this equation. So now we have this vector, and what we're going to do is we're going to take this point and put it into the formula for L of t, the tangent line. So L of t is equal to this vector times t plus our point in vector form. Negative root 2, negative root 2, and 1. And that's it. You can also multiply this out to have it in vector form, where you just have one vector. So for example, the first one is negative root 2t